consider the discrete time linear causal system described by the difference equation. Obtain direct form 1 and direct form 2 realizations. The scheme steps 2 marks, direct form 1 realization 4 marks, direct form 2 realization in 4 marks. So in this type of questions, it is better to convert it into frequency domain by taking the Z transform on both sides and get the system function h of z. So given the constant coefficient difference equation, now taking Z transform on both sides, we get y of n will become y of z, then minus 3 by 4 y of z is to minus 1, etc. From which we can determine the system function h of z, which is equal to y of z by x of z. Y of z by is x of z will be equal to 1 plus 1 by 3 z inverse divided by 1 minus this step. Next, let us draw the direct form 1 structure. So in the case of direct form 1 structure, the numerator coefficient, that is the b coefficients, comes in the left side of the structure, whereas the denominator coefficients, that is a's coefficients, at the right side. Then we know that always the numerator coefficients, that is the b coefficients, in the forward direction, whereas the a coefficients always in the reverse direction or the feedback form. And here we can see the numerator, you have only one delay, and the denominator we have two delays. So for a direct form 1 structure, as a first step, we can draw two adders side by side. Now we can connect the two. Now at the right side we have two delays, so that we have two adders and two delays. So the next adder we can draw directly below this one. Now the delay element can be drawn in midway at a distance. Then draw the second delay element just below at a distance below this position. Now we can connect these two. Then we know that this arrow mark will be the feedback arrow mark will be upper side. Then draw this one and connect these two. And we can draw the A1 coefficient so the arrow mark here will be in the reverse direction. The arrow mark in the reverse direction, whereas the A0, which is always 1, is in the forward direction. Now the numerator side. So in the numerator side, or the b's coefficient, we have only one delay, which can also be drawn at this position. Then we can connect and here it is B0 equal to 1 itself, then B1 is 1 by 3. Here or the A1 is minus 3 by 4, so this will be 3 by 4. A2 is 1 by 8. The corresponding A2 written here as minus 1 by 8. A2 equal to minus 1 by 8. Then give the input x of n, then the output y of n, and put all the relevant arrow marks. Now the direct form 1 structure is over. Now let us draw the direct form 2 structure. In the case of direct form 2 structure, the numerator coefficients, that is b's coefficients, comes to the right side of the structure, and the a's coefficient, denominator coefficients, comes to the left side. Here you can see the number of delays, maximum number of delays in the system is 2. So first of all we can draw the delays. Draw the 2 delays in this pattern. Now the B1 coefficient we can draw like this. This is 1 by 3. Now this A1 coefficient is just in the reverse direction, which is 3 by 4. And here we have the adder. Now the B2 coefficient. B2 is minus 1 by 8. Then connecting these two. Now you have to connect here. The B1 coefficient is 1 and A0 coefficient is always 1, and A0 in the forward direction, whereas all other A's coefficients in the reverse direction. The B0 coefficients in the forward direction. Input x of n, output y of n. This is the direct form 2 structure. So we have finished solving this problem. Thank you.